Students, this is Amuda R, Assistant Professor from the Department of Robotics and Automation. Our subject code is MR3491. Our subject name is Sensors and Instrumentation. Today, I'm going to discuss about in third unit the topic of magnetic sensor. This is a part 2 video. Magnetic sensor, the types, principles, requirements, and the advantage. So what is magnetic sensor? So which sense and notice the disturbance as well as the changes within the magnetic field. So that disturbance or changes that may be strength, direction or flux. So different types of detection sensors are there. So that is light, pressure and temperature in magnetic field only. Okay, magnetic sensor working in magnetic field only, that senses strength, direction, flux. Okay, and these sensors are separated into two groups. So first one is used to calculate the total magnetic field, and second one is to calculate the vector components of a field. So this is the diagram of a magnetic sensor. It's looking like this. So next one is a principle of a magnetic sensor. The magnetic sensor comprises a chip with a magnetoresistive component. Actually it is a chip. It have the magnetoresistive component. So which is used to detect a magnetic vector and magnet, intended for magnetic vector, actually, which is detected by the magnetoresistive component. If any changes will occur, then the magnetoresistive component have some resistance that will be changed. Okay, so the chip which is used in a sensor can be used for sensing the change within the magnetic vector. So that this vector notices the behavior of magnetic body depending on the change of resistance value of the magnetoresistive component. If any changes will occur, then the resistance of magnetoresistive component will be changed. Okay, so in magnetic field, so types of magnetic sensor. So is have the three types. One is a low field sensor, another one is a earth field sensor, bias magnetic field sensor. Low field sensor means it detects extremely low values like the magnetic fields like 1 UG, that is 1 Gauss is equal to 10 to 4 Tesla. 1 UG up to 1 UG. Okay, so which is used in medical fields. Okay, earth field sensor, this magnetic sensor used in navigation direction, but this type of sensor ranges from 1 UG to 10 G. Okay, 10 Gauss. And bias magnetic field sensor, which are used in Hall devices, that is current measuring devices, GMR sensor, reed switches. So these are all uses the bias magnetic field sensor, which ranges, which in these ranges is 10 Gauss, above 10 Gauss. Okay, so these are the three types of magnetic sensor. So this is the angle magnetic sensor, the target magnet and the magnet angle sensor having the sensing element, A to D converter, low pass filter, which gives the digital output. The target magnet is a permanent magnet which gives the speed or direction, that may be anything from the magnetic field. And this sensing element, A to D converter, low pass filter, I already discussed in the many topics, so I think you know already. Okay, so next topic is a Hall effect sensor. First one is a magnetic sensor, another one is a Hall effect sensor. Hall effect sensor is nothing but it's a current measuring sensor. Current measuring sensor. So which produces the voltage differential across the conductor when the magnetic field is applied across the cross section of a current carrying conductor. Okay, so here is this is the Hall effect element, right? So from this we can measure the current. So this pin 1 and 3 is connected with the current, and 2 and 4 it connected with the Hall effect voltage. So this voltage will give the output as EMF, electromagnetic force. It gives the electromagnetic force. Is the Fleming left hand rule, because it follows that Fleming left hand rule only. If current increases, the magnetic field direction. If any changes in the current, then the magnetic field direction will be changed. So that is the Fleming left hand rule, right? So next one is a magnetoresistive element sensor. Next topic is a magnetoresistive element. Already we know a magnetic sensor having the magnetoresistive element. So here this is the another prominent form of magnetic sensor. When a magnetic field is applied across the magnetoresistive element, its resistance varies. Already I told its resistance varies. So there is three elements are there. So three popular types. One is a anisotropic magnetoresistive element, another one is a magnetoresistive element, that is gained magnetoresistive element, another one is a tunnel magnetoresistive element. So first one is a anisotropic magnetoresistive element. So this exposed to the magnetic field used by AMR sensor. So change in the resistance of ferromagnetic materials, if any change in AMR sensor, right? So before that, the magnetoresistive ratio is very much important to measuring some currents or anything. So maximum the MR ratio of roughly 5%. Okay, so here AMR sensor element as a ratio is 5%. So here is the there is a only one film in this. Only one film is there, only one layer is there, that is ferromagnetic film. That's a free layer. So the current direction and the magnetization direction also the same in a parallel. In a vertical, it's also same. Okay. So next one is a gained magnetoresistive sensor. So which is based on the thin film construction made of alternating ferromagnetic and non-ferromagnetic layers. So here it is that blue color indicates the ferromagnetic free layer. Already we know in AMR sensor we already seen that. Next one is a non-magnetic metal that current is flowing between that and ferromagnetic film. This is a pinned layer, that violet color. So here the current direction and the magnetization direction in opposite, in anti-parallel, but in parallel current direction and also the magnetization directions are the same. Okay, here the ratio is 20%. Next one is a tunnel magnetoresistive sensor, which have the ratio is 100%. But here the difference is the in anti-parallel the current direction is in vertical. So for the perpendicular to the magnetization direction, in a parallel also perpendicular to the magnetization direction, the current direction. But for this magnetization direction is different for anti-parallel and the parallel sensors. Okay, so application of this is industrial automation, industrial electronics and consumer electronics. So these are all the application for the these sensors. So if you have any questions or any doubts, please drop the comment below. For more lecture videos, visit our website smit.edu.in and follow our Facebook page SMIT Chennai and follow our Instagram page SMIT official channel. Thank you.